we're going to look at limit laws. So we're going to end up taking limits algebraically, but it would be nice to have shortcuts and certain properties we can use to make our limit solving easier. So for the next few slides, I'm going to let c be a constant, which is just any number. I'm also going to let f of x and g of x be functions, where the limit as x goes to a of f of x is equal to f, and the limit as x goes to a of g of x is equal to g. And of course, I'll reiterate this when we get to the important laws that require these things, but these laws I introduce are going to make things much easier for us to deal with algebraically. And of course, you would prove these in a later analysis course, but for this course we won't prove them, we'll just show them with an example. So the first law says, if we have the limit as x goes to a of f of x plus g of x, so two functions put together, this is just the same thing as taking the limit as x goes to a of f of x and then adding the limit as x goes to a of g of x. So we could break up a complicated function into two different functions and take the limit of them separately, or we can take two limits and merge them together and take a limit together. So here's an example. The limit is x goes to 2 of x squared plus x plus 1. And here I've very clearly shown them as f of x and g of x. So on the right hand side I'm going to take the limits of them separately, and on the left hand side I'm going to take the limit together and show that they're the same. So on the right hand side, what we're saying is that we can break it up into two limits. So we can say the limit is x goes to 2 of x squared plus x, and then we can add the limit as x goes to 2 of x plus 1. And in all of these examples, we can really simply just plug in the value for x. So on the right-hand side, that would just be 2 squared plus 2. And then we'd add that to the limit as x goes to 2 of x plus 1. Again, we just put in 2 for x, and that's going to be 2 plus 1. Okay, let's add these together. So this will be 4 plus 2 plus 3. So our total will be 6 plus 3, which is 9. So that's taking the limit separately. But let's add these functions together. So let's simplify this first. X squared plus x plus 1. Well, this is just the same thing as the limit as x goes to 2 of x squared. We'll group our x's together and make 2x, and then add 1. So now we've combined the functions. This is f of x plus g of x now. And let's take the limit as x goes to 2, so we can just plug in 2. So this will be 2 squared plus 2 times 2 plus 1, which is just equal to 4 plus 1, which is equal to 9. So these are equal. And in a later course, you would prove the limit laws using the definition formally. But we can see here that if we have two functions, we take the same limit, then we can take the limit either together or we can take them separately and it'll come out exactly the same. The second law is a multiplication law. Essentially, if you have the limit as x goes to a of some number times a function, so again, this is just a constant, it's any number, then it's just equal to that constant times the limit as x goes to a of f of x. So we can just pull the constant out of the limit. So here's an example. The limit as x goes to 2 of 3x squared plus 3. If we just put in 2 and evaluate it like this, then we'll have 3 times 2 squared plus 3, which is equal to 3 times 4 plus 3, which is just 12 plus 3, which is 15. But another way we can do it is we can pull out this constant factor of 3. So now this would be 3 times the limit as x goes to 2 of x squared plus 1. So this is equal to 3 times, well, let's put in 2 now. So this will be 2 squared plus 1, which is just 3 times, well, 2 squared plus 1 is the same thing as 5. So 3 times 5 is just 15. And again, we can see that these values are the same. So sometimes it's easier to pull out a constant factor because it makes multiplying all those other numbers much easier than just including them into every term. So that's a nice multiplication law for limits. The third law is that if we multiply two functions together and take their limits, we can just take their limits separately and then multiply the limits together. So here's an example. The limit is x goes to 2 of x squared plus 2x plus 1. Well, we can factor this. So let's factor this. This is just the limit as x goes to 2 of, well, this would be x plus 1 times x plus 1. Okay, so this kind of fits our pattern up here. So f of x is x plus 1 and g of x is x plus 1. So now we can split these up. So we can just take the limit as x goes to 2 of x plus 1, and then we can multiply it by the limit as x goes to 2 of x plus 1, and this should be the same thing. So the limit as x goes to 2 of x plus 1 is just going to be 2 plus 1. We'll multiply that by the limit as x goes to 2 of x plus 1, which is also just 2 plus 1. So this will end up being 3 times 3, which is 9. And if we just plug 2 into all of our x values here, which we've already done before, this will be 4 plus 4 plus 1, which is just equal to 9. So we can see that even if we multiply two functions together and take their limits, we can just take the limits separately and then multiply them together later. Which, if you're dealing with something like x to the 5th, x to the 6th, it might be easier to break them down into two factors of x cubed, or maybe an x squared and an x cubed, and then take the limits separately just to make it easier for your computation. So this is a limit law you can use to make your computations a little bit easier on an exam if you see that it can be done. The last law I'll talk about is the division law. So the limit as x goes to a of f of x over g of x is just the same thing as the limit as x goes to a of f of x over the limit as x goes to a of g of x. But that's only if the limit as x goes to a of g of x is not equal to 0. In other words, what this says is don't divide by 0. Otherwise, it's bad. So here's the example. The limit as x goes to 2 of 3x over x squared plus 1. If I just plug in 2 for these values, this will be 3 times 2 over 2 squared plus 1, which is just equal to 6 over 5. So let's just keep this in mind that if we evaluate it like this, this is just equal to 6 over 5. But we can take the limit individually. So we can take the limit as x goes to 2 of 3x, and we can divide that by the limit as x goes to 2 of x squared plus 1. And if we plug in some values, we see 3 times 2 is just 6. And if we plug 2 in for x on the bottom, it'll be 2 squared plus 1, which is equal to 5, and these are exactly the same. So again, these might be really obvious to you, but there's a lot of mathematics behind it that we have to formally define in order to prove these things. We're just taking them for granted for now. But these are really important rules that you can use when you have to do your computation questions and mechanical questions on your exams in your course. So here's a practice question, and I'm going to do all these laws individually just so we can see how they work. So I can take everything at once. I can just plug 5 into these values, except we're going to get some big numbers to deal with. I mean, they're going to be big regardless, but let's just show how we can use limit laws to simplify this a little bit. So the first thing I can do is I can use the multiplication law, and I can pull out a factor of 5 from everything. So I can just take the 5 out, and then this will be the limit as x goes to 5 of, well, this 10x squared would become 2x squared, the 5x would just become x, and the minus 20 would become minus 4. Okay, the next thing I can do is I can take all of these limits individually instead. So I can do it 5 times, and then this will be the limit as x approaches 5 of 2x squared plus the limit as x approaches 5 of x plus the limit as x approaches 5 of 4. Okay, so at this point you might be thinking, maybe we should just do it the original way, it's faster, and indeed it is faster, but just to really demonstrate these laws. I'm going to do it step by step like this. So this will be 5 times, well, in the first case we can pull out a 2. So this will be 2 times the limit as x goes to 5 of x squared plus, well, the limit as x goes to 5 of x is just 5. What about the limit as x goes to 5 of 4? Well, there's no x there to plug into, so it's just going to be 4. Okay, so this will be 5 times, well, so we're going to have 2 times the limit as x goes to 5 of x squared. What is the limit as x goes to 5 of x squared? That'll be 5 squared. So this will be 2 times 25, because 5 squared is 25. Then plus 5 plus 4, that's just plus 9. So this will now be 5 times, well, 2 times 25 is 50, plus 9 is 59. And now we can see this will be 5 times 59, which is just 250 plus 45, so this should be 295. And that's showing all the limit laws. Of course, it really is faster just to plug in 5 into x up top. So this would be 10 times 5 squared plus 5 times 5 minus 20. Okay, I did make a mistake here. So this should be minus 4 in all of these. This should be plus 1, which would be 51, which would be 255. Okay, I did, of course I missed a negative sign. So this would be 10 times 25, which is 250, plus 5 times 5, which is 25, minus 20. So this would be 275 minus 20, which is just 255. So we can see that they're both exactly the same. One is quicker, of course, but the other is taking each limit law and doing it step by step, which, of course, with more complicated questions will be very useful. If you have any questions, please leave them in the comments below, and I will do my best to answer them.